This video we're going to talk about types of bonding and formation of ions. In the previous chapter, you should learn that different substances, they may have different electrical conductivity. For example, conductors. We were saying that some of substances that can conduct electricity in both solid and liquid state. So example for this, we will have metals and also graphite. Remember, graphite is a non-metal, but it can conduct electricity. While opposite to conductors, we have non-conductors, and we may also call that insulator. So for insulator, those are substances that cannot conduct electricity. Example for that will be the non-metal. Remember, except graphite, say for example, iodine, sulfur, carbon, and also most of compounds made up of non-metals, only non-metals. For example, you have like H2O, hydrogen, oxygen are non-metal. Ethanol, you can see only you have carbon, hydrogen, and oxygen. These are also compounds that cannot conduct electricity. While in the middle, we do have something called electrolyte. You may not be very familiar with these terms, okay? But electrolyte are substances that can conduct electricity only when molten or in aqueous solutions. That means when it is only in liquid state or it looks like to be liquid, they can conduct electricity. Not only this, okay, you'll find that they will decompose by electricity during conduction. They will decompose, they will be broken down into two different things. This is not the key focus, okay, of these sections, okay? But I just want to tell you that different substances, they will have different electrical conductivity. But why it will be like that? The main focus is because the electrical conductivity of substances, they are affected by the chemical bonding within them. So what is chemical bond? Chemical bond, we're referring to the electrostatic attraction. Electrostatic attraction is attraction between opposite charge particles, and these attractions will hold particles together in the substance, and we call this chemical bond. You should know that, okay, we have 118 elements in this world, but we are not only having 118 substances, okay? Even for me and you, okay, we are made up of many different elements. So these elements, they have to stick together, they have to be held together to form something new. So the attractions holding these elements or atoms together, we call these chemical bonds. So you can see that, okay, we are talking about the attraction between opposite charge. So we have many different kind of chemical bonds. I'll just show you three of them right here. So these are also having opposite charge attracting to each other. Say for example, the first one, okay, on the top left corner, you see we have negative charge, positive charge, negative charge. So therefore they will attract each other because positive and negative will attract together. And then the one right here, okay, we have positive charge ions, this one, positive charge ions. And we also got negative charge electrons. These are the negative charge electrons. So we also have attractions between these things, okay? They will hold them together. We'll hold them together like this way, okay? But this one, okay, will be a little bit difficult for you to see, okay? You can't see the positive and negative. So what are these dot represent? These dot and cross, okay, they are representing electrons. And we know that electrons, they carried negative charge. While the one in the center, actually, that is the nucleus. So we can think about like this. We do have the nucleus, we have proton in it. This is positive because we have proton inside. And also, of course, they have neutron, but neutron have no charge. So we know that the nucleus, they should be positively charged. And then the electrons in the middle, okay, they are negative. So therefore, again, you will see the positive and negative attractions, okay? So all these things, we call that electrostatic attractions, and we refer them as chemical bonds. So how many types of chemical bonds do we have? First of all, these chapters, okay, we're going to talk about the ionic bond. Ionic bonds, okay, we're referring to the compounds. Compound means made up of more than one kind of elements. For example, we have NaCl, MgF2, okay? So these are the compounds. We have two capital letters for that. Remember that, okay? So in compounds, okay, they are formed between metals and non-metals. So if you have the compounds made up of the metal, Na, Mg, they are group 1, group 2 elements. Non-metal, Cl, F, they're coming from group 7. So we call this kind of compound, and the bonding in it, we call that ionic bond. And metallic bond, okay, we're referring to the attractions between the metal atoms, okay? So all these, okay, they should be referring to the metal. Say, for example, Na, Mg, aluminium, things like these, okay? So metallic bond only happens inside metals. Lastly, okay, that will be covalent bond. Covalent bond, we're referring to the attractions between the non-metals. Okay, and also we have compounds, but this time the compounds, okay, they are formed from non-metals only. So example here, you see HCl, we have H2O, we have NH3. All these things are non-metals. Okay, so in non-metal elements, okay, we may have like sulfur, we may have like nitrogen, oxygen. All these, okay, they are also coming from non-metals only. So the attractions between these, we call that covalent bond, and we will learn this one in chapter 8. So in this video, we're going to talk about ionic bond. So before we talk about the ionic bond, we have to learn about ions. So why do we have ions? Why do we need to form ions? So you can have a look of this. For the atoms, if you still remember, okay, for noble gases, they will have octet structure and duplex structures. That means in the outermost shells, they got 8 electrons. You can have a look of this one. 1, 2, 3, 4, 5, 6, 7, 8. So it is so balanced. So for these noble gases, we will say that they are not stable compared to the other atoms. However, some of the atoms, if they don't have without octet structures or duplex structures, say for example, all the atoms coming from group 1, 2, group 7, all of them, they must not have 8 electrons in the outermost shells. So by then, okay, we will say that they are not stable. If they are not stable, they will try to work out how to achieve to be a more stable structures. What they can do, they can achieve that by gaining or losing electrons. So say for example, in oxygen, we see that, okay, they have 6 electrons in the outermost shells. So if they want to become octet structures, there are 2 ways to do that. One will be gaining 2 electrons. The other one is losing 6 electrons. So if they gain electrons, they will become 2, 8. And if they lose electrons, they will become 2. So because there is attractions between the proton and the centers with the electron outside, if you try to lose 6 of them, that will be too much for them. So therefore, the proton will not allow this thing happens. So in this case, losing 6 electrons, that will be too much. So for oxygen, they will then use gaining electrons to help. And for potassium, you see 2881. One in the outermost shells, which is also not octet structures. So what they can do, they can be doing by gain 7 electrons, or they can do by losing 1 electrons. So obviously, losing 1 electrons is easier. They can then form 2, 8, 8. So they will have 8 in the outermost shell electrons. They need to gain 7 electrons. It's difficult because every electrons, they are negatively charged. And at that time, okay, the number of proton in the center, it still be 18 proton. There are no extra protons there to attract these extra 7 electrons. So between these 7 electrons, they will also have great repulsions. They don't like each other because the similar charged particles, they will repel each other. So the electrons, they will push others away. So holding extra 7 electrons is too difficult for potassium to achieve that. So therefore, in this case, they will lose the electron instead. So you can see that, okay, the atoms, if they are not stable, they will achieve a stable structures, that means octet structures, by either doing gaining electrons or losing electrons. So in the following, we're going to in details to look at how the things gain or lose electrons. But before that, okay, we have to talk about the type of ions. In general, okay, we say that, okay, ions can be categorized based on their charges, okay, based on charges. So I'll just do this metaphors. Cation, you see CAT, okay, you can see this lovely cat, okay, don't touch my human, okay, so you can see that they are good guys, okay, so the cat, okay, that will be the positive charge. Or you can think like this one, cation, okay, so you can see the positive hide within it, okay, so cation, we are referring to the positive charge ion. Say for example, this is cation, this is cation, these are the cation, these are the cation, okay. So for anion, okay, we can't see the exact word, okay, but you can think of like ants, okay. Okay, ant, okay, is some insects that not everyone like, okay, so you can see this, okay, look like to be an ant bad guy, okay, so anion, okay, we are referring to the negative charge ion. So say for example, we have these are the negative ion, we have like negative ion, okay, so the negative charge ion, we call that anion. Positive charge ion, we call that cation. So let's have a look at formation of cation. So right now, okay, we got a sodium atom. Pay attention to the name. It is called sodium atom. Atom, we're referring to same number of proton, same number of electrons, okay, the number they should be equals. So in this case, okay, we have in the atoms we have 11 proton and 11 electrons. So because 11 proton equals to 11 electrons, so we say that they are electrical neutral, so they have no charge in atom, okay. But if we want to achieve a octet structures, basically they can do this by losing one electron. After they lose one electron, they will become 2-8, and the number of electrons, okay, will become 10 in this case. Remember, we are just removing the electron out from the outermost shells. We have nothing to do with the proton or the nucleus inside. So you can see that, okay, the number of proton is still the same, but this time the electrons will become 10. In this case, okay, we can see that 11 proton is more than 10 electrons. Okay, so therefore we have one positive more. Okay, so after all, you'll find that sodium, we have a positive charge, okay, to represent. Okay, so what you need to do, we just eliminate, okay, the outermost shells. We don't have these outermost shells. Putting cross is not good. Okay, so we have just eliminate this outermost shells. I just highlight to show you. These outermost shells, we don't draw it anymore. So we just have two shells right here, and then we put a square brackets there, and then we show the charge. Okay, in this case, it is one positive charge, but we don't write one positive. Remember, we just have positive. And then our second example, formation of cation, another one. So magnesium is 282. So what we need to do is losing electron. But this time we are not only losing one electron, but we are losing 2 electrons. Again, we don't draw the outermost shells, so we just draw the 2 inner shells. So you can see that, okay, we just have 2 shells here, 2 electron shells here. Okay, but the charge this time is different. Original in atoms, okay, in the magnesium atom, we have 12, okay, they are electrical neutral, okay, because proton equals to electrons, okay, 12 proton, 12 electrons. But this time, after losing 2 electrons, they become 10. So in this case, you'll find that 12 proton is more than 10 electrons. So in this case, okay, we have 2 positive more than the electrons. So you find that, okay, we will have 2 positive to show the charge of it. Remember, all the time, number goes first, and then charge after. Okay, so this is how we draw the formation of cation. Okay, so some of the points, okay, you can see aluminium here. So aluminium is 283. So what they need to do is lose 3 electrons. Lose 3 electrons, that means you got 3 proton more. So we become 28 and then 3 proton more, so that will be 3 positive. Okay, so remember, in the center, you should have the atom symbol in the center. Okay, you should have an atom symbol in the center. You should have the correct number of electron shells. For cation, they lose the outermost shells already. So therefore, you have one number of electron shells reduced. And then you draw square brackets. Don't draw something like this one. Okay, so say for example, you draw this one like this, then will be a wrong one, a totally wrong one, because this is not a square bracket. The simple atoms in the middle is wrong. The number of electrons is wrong. And also remember the charge. Number go first, charge at the back. So all these things are wrong. Okay. So remember, okay, a correct electron diagram should be written like this. So next we talk about the formation of anions. Okay, so this one is 287. So obviously you need to gain 1 electrons. After gaining 1 electron, it becomes 288. Okay, so at the beginning in atom format, okay, that will be 17 proton, 17 electron. So that is electrical neutral. Okay, and then for ion, okay, because we want to become octet structure, so you gain 1 electron, become 18. So in this case, we have 70 proton, but electron got more. You have 1 negative more than a positive. So therefore, eventually, this is a negative charge. But this time, remember, we are gaining an extra electron. We are gaining extra electrons. So we will have, in this case, we have 3 shells. And in the ion, we also keep 3 shells there. But remember, because we are gaining an extra electron, which does not belong to chlorine atom, so this extra electron, we use a cross to represent. Okay, remember this kind of electrons diagram, we call that cross and dot diagram. So therefore you can use either cross or dot to represent. Say for example, one day you want to use cross to represent the electrons. It is okay. You cross like this. Okay, you cross like this. These cross are the original electrons. And then you use a dot to represent the extra one. Remember, square brackets, and then you got a negative charge for that. That is also okay, acceptable. And then now we talk about the formation of anion, okay, oxygen. 2,6, obviously, you need to gain 2 electrons. After gain 2 electrons, become 10. So you have 10 electrons. 8 protons, so you have 2 negative. Okay, 2 electrons more, so we become 2 negative. Again, remember, not negative 2. Okay, and then these extra electrons you use cross to represent, and you can see a square bracket right there. So this one more or less the same. Just remember, have a different symbols to represent the extra electrons. Again, okay, numbers, okay, have to go first, charge at the back. So you should have 3 negative, 3 negative, 2 negative, like this way. So to summarize, okay, electrical conductivity of different substances, they are depending on the chemical bonds in it. Okay, depends on the chemical bonds in it. Okay, and there are 3 types of bond. With ionic bond, which happen between the metal, non-metal, and we have like, for example, K2O. Okay, and then we have metallic bond happen inside the metal. For example, we have copper, aluminium, magnesium. With covalent bond within non-metal, okay, say for example N2P4. Okay, we have compounds which only have non-metals. For example, NH3, okay, PCl5, okay. So these are 3 types of bonding. And the atoms, okay, if they are not stable, they don't have octet structures, they will try to have octet structures by either gaining or losing electrons. And then because of this unbalanced charge between the protons and also electrons, where they give rise to the charges of ions. So you have positive, you have like 2 positive, 3 negative, 2 negative, things like this. Okay, writing an ion, remember symbol in the center. Extra electron use different symbol, for example like this, with square brackets, and number always go first, and then charge coming at the back. So that's all for this video. Bye bye.